All right, Quincy, I'm going to try to answer some of your questions. One of them, you asked about holes, and you also asked about actually graphing rational functions. So I want to give you a little bit of tidbits on that. So I'm going to look at a function. F of x is equal to, we'll do x plus 5 in the numerator over x squared plus 6x plus 5. So I think this will give us a good idea and give you a good idea about how I'm going to graph this rational function. So your step one is really to simplify your function. And by simplifying it, I mean factor out any expressions that you have and see if you can essentially simplify the function. So if I look at 5, factors of 5 that would make 6 are 5 and 1. And then hopefully notice that in this function, the numerator and the denominator have a common factor, x plus 5. So I can simplify this function and get 1 over x plus 1. All right, so now when I go to graph the function, what I need to do is I need to identify the horizontal asymptote, the vertical asymptote, and the y-intercept. So I want to know what is my horizontal asymptote, what is my vertical asymptote, and what is my y-intercept. So we can identify the vertical asymptote based on the denominator. So if you look at this denominator, we have an x plus 1. I want to really just know where is this value discontinuous? Like what value can I substitute in for x? And the only value you're not allowed to substitute in is -1. And that's because it would cause the 0 in the denominator. The next thing that you want to look at is what is going to be the horizontal asymptote. And a horizontal asymptote is really just a horizontal trend line. Like what is this function trending towards? If I were to put in a really large value, or if I was going to put in a really small value, really like negative value, what's going to happen to it? So think about putting in a large number. If I put in 10, getting out 1/11th. That's a fraction, pretty tiny. If I put in 100, getting even tinier. If I put in 1,000, even tinier. And what happens is this fraction is getting smaller and smaller and smaller and smaller, and it's trending towards nothing, right? The smaller the fraction, the closer it's getting to 0. And that's why your horizontal asymptote trends towards 0. And then my y-intercept. So the y-intercept is just a point where the x value is 0. So if I substitute in 0 to this, I get 1 over 0 plus 1, which equals 1. So I have a y-intercept at 1. Now I can go and sketch a graph. This is not perfect. It's really just an image of what I would expect to see if I were to put this function into a graphing calculator. So I have a horizontal asymptote at 0. That means my function is going to trend towards this line. I have a vertical asymptote at -1. And then I have a y-intercept at 0, 1. Okay, so that means my graph is going to trend towards this line, and it's going to trend towards this line. So I have a curve that looks like this. And what we noticed when we studied rational functions is that oftentimes these functions trend diagonally. So if there's a curve here, there tends to be a curve here. And we can check that by putting in a number to the left of our asymptote. If I substitute in the number -2, I get 1 over -2 plus 1, which is 1 over -1, which is -1. So when I put in a value of -2, I'm getting out a value of -1, which is exactly what I would expect. And most rational functions kind of follow the same trend. The only time you see rational functions kind of behaving a little bit more different is when you see something like this. F of x equals 1 over x plus 2 squared. And if you think about what is going on with this function, I have a vertical asymptote at -2. If I put in a value of 0 to find my y-intercept, I get 1 over 0 plus 2 squared, or a quarter. So I have a y-intercept pretty tiny. It's going to trend towards 0, right? Because the function is becoming a smaller and smaller fraction. So I have a curve here. But if you think about this, my values that I'm getting out for this function are never going to get negative. Whenever I square a value, it's always going to be a positive version. So if I put in 5, that's going to give me 1 over 49. If I put in negative 5, that gives me 1 over negative 3 squared, which is positive 9. So what happens with this function is that you actually get two curves side by side. You'll never get out a negative value because of the square in the denominator. And the last one that sometimes feels a little bit odd to students is something like this, 1 over x squared minus x minus 2. Same concept as before. I'm going to factor this, 1 over x minus 2, x plus 1. And I have two vertical asymptotes, right? One at 2 and one at negative 1. So when I go to sketch this graph, I'm going to have one at 2 and one at negative 1. Again, still a 0. Okay. And when I put in my 0 value for x, I'm getting 0 out negative 1/2 over 0 down 1/2. So what's happening is here I get a curve in the center, almost parabolic looking, but it's not actually a parabola, it's just a center looking curve. And then if you were to substitute in a value here, you would get out another function that exists to the right and another function that exists to the left. Okay, so that's really what we studied when it came to rational functions. But we talked about something else about this function up here, is that when we simplify it, there's a piece to this graph that we did not include. So we have our great asymptotes, the curve's doing all of its thing, but we never noted the fact that my original function had a domain restriction. I was not allowed to have the value of negative 5 in this function. So what we call this is something called a hole. It's the value that was simplified out, but in my original function, I can't include it. So if I take this value of negative 5 and I substitute it into my simplified version, I get 1 over negative 4, or negative 1/4, which means in my function, when I go left 5, there is a value that I cannot include, and we note this with an open circle. It's saying that there should have been a vertical asymptote here, right? There should have been a value that wasn't included in my domain, but it simplifies out so I don't get a vertical asymptote. I hope that bit makes a little bit of sense to you. And then your last question was really just about, and I'm running out of paper, I'm gonna come over here, about horizontal asymptotes and how you figure out that. So really there's 3 scenarios that we examined. There was functions that we just looked at where you have a degree in the numerator that is smaller